Hi guys, my name is Blessing. Yeah, I'm an ambassador of QuickNode. And in this tutorial, we'll be looking at mastering in Solidity, looking at the base of Solidity by writing a simple storage smart contract using QuickNode RPC. So fast forward, we'll be looking at what a smart contract is. Yeah, a smart contract codes. Smart contracts are like computer programs that runs on a blockchain. Blockchain is a special type of digital ledger that records transaction and data in a secure, transparent, and immutable manner. Smart contracts are stored on a blockchain, and their code is executed automatically when certain conditions are met. So now, writing a simple storage smart contract, you would head over to our Remix IDE, and this is my code already. This is my code, full code. I'll be explaining this code in details for you guys, so you guys will understand and also be able to break it down. For any for any smart contract code you want to write, you have to state the license there. This is MIT. This license states that it's an open source. That means anybody could fork it and also contribute to it because it is not privatized. Secondly, we will be looking at the compiler versions of our smart contract. Pragma Solidity 0.8.0. This is the like approved or the approved compiler version to use in any smart contract codes you want to be writing. Before we write any smart contract, we have to specify the name of the smart contract. Here we specify that as simple storage smart contract because it defines a new start of a code. Yeah. The second variable here is the uint 256 private stored data. It declares a private variable called state stored data of type uint 256, meaning uint 256 means unsigned integer of 256 bytes. To all the stored value, the value is marked as private, meaning it can be accessed within the smart contract code itself. Then here, if you notice, you see a set of event variables here stated here. It defines a series of events. An event is a way to log and notify external observers about specific actions happening within the contract. They provide transparency and allow external parties to track contract interactions. Next type of variable here will be the function. This function store data is updated when the new value with the new value, and then the value set event is emitted with sender's address, message or sender, and the new value. Yeah. The second type of function is the get function. The get function does not modify the contract state and can be called by anyone. It returns the data value, the current value of stored data. The next function is the increment function. This function adds the value to the current value of stored data. Function decrement, then the next one, function decrement function. The function subtracts the value of the current value from the current value of the stored data. Next one, the function multiply. Function multiply multiplies the current value of stored data by the provided factor and then emits the value multiplied events. If you want a very detailed and broken down explanation of this code, you can check the article below in the description in the description comment description section. Sorry, yeah, so that you could see it and understand it, and of course you to apply it to anything you want to build on the blockchain. The next function is the function divide. You see the function reset. They all do similar. They all do respective functions as they are stated in the code below. And lastly, the last function I would likely to want to understand, I want you guys to understand, is the function square root. The last function, function square root, defines a public function named square root. You get it. This function returns the square root of the current value of the stored data by calling the internal square root uint x function. It defines an internal pure function named square root uint 256x for calculating the square root using Newton's method. Function iteratively refines and estimates z of the square root until it converges to the accurate value. The function is internal, take note, which means that it can be used within the contract itself and is pure at the does not modify state. So here we'll be deploying this contract using QuickNode RPC on separate testnet. Yeah, a method for doing that, a procedure of doing that is in the article below in the description section. You should check it out and see how to add quick RPC manually to your MetaMask and you deploy it through using Simpler. Yeah, so yeah, I've added it already automatically. See, it's successfully compiled, and yeah, so I'll just be deploying straight up. So when you deploy this, it gives you, it asks for you for access to your MetaMask, especially if it is connected. Yeah, you see, yeah. So basically, you've deployed your contract on chain. You could check it on Etherscan, and yeah, don't forget how to get your QuickNode RPC. You navigate to QuickNode's dashboard. You create an account if you don't have an account. Then navigate to the endpoint and copy your code and copy your your RPC, yeah, your on chain, your online URL for QuickNode, and then add it manually to your MetaMask. Thank you very much for staying here. Thank you very much, guys. Bye.